Welcome back to Water Quality in the Pacific Northwest. We are in a large unit entitled Surface Water Quality. We're taking a look at both pollutants and measurements of pollutants. Today we're going to look at component C, erosion on land. We've talked about nutrients. We talked about sediments. You've got to recall that sediments and erosion are very highly related. So today we will start by talking about Lecture 12, Erosion on Land. Erosion can be caused by many things. It can be caused by water, wind, or tillage. Erosion is a naturally occurring process that affects all landforms. It is more serious where it has been accelerated by humans. There are three distinct parts of the erosional process. First, we have soil detachment. Second, soil movement, and finally, sediment deposition. Usually when we're talking about erosion, we're talking about the loss of topsoil. Topsoil is the portion of the soil near the surface, and this topsoil has a higher proportion of organic matter and phosphorus. In the United States, most erosion comes from croplands and rangelands. It can be said the same across the planet. We have an agency that deals with erosion, the United States Department of Agriculture Natural Resources Conservation Service, often abbreviated NRCS, is the agency that's charged with erosion prevention in the United States. The agency was founded because of the Dust Bowl days on the Great Plains in the 1930s. Here's a picture of Dust Bowl days in Oklahoma, where basically there was nothing holding soils together. We had a prolonged drought and millions of acres of farmland, and many hundreds of thousands of people were displaced because of this crisis. So today, the USDA, Natural Resource Conservation Service, has been successful at reducing the rate of erosion on agricultural land. We haven't stopped erosion. You will never completely stop erosion, but the rate of erosion on agricultural land has decreased very markedly. Erosion rates are considered to still be above a sustainable level. A sustainable level of erosion would be the amount of topsoil that is produced through geological processes on an annual basis compared to the amount of topsoil that is lost by erosion. As long as the amount of topsoil lost by erosion is greater than the amount that is made by geological processes, we're at an unsustainable level. And even though the rate of erosion has been decreased, rivers of the United States are still laden with soil materials. It's still a major problem. The Natural Resource Inventory, or what's called the NRI, is a statistical survey of natural resource conditions in the United States. This survey shows the reduction in soil erosion over time, and it highlights the most erosive agricultural areas in the United States. So this is very good for our frame of reference as to what is the erosional situation, where are the hot spots, what kind of progress have we made. If we take a look at some of the important findings from the NRI, we see that between 1982 and 2016, soil erosion on USA cropland decreased by 52%. Tremendous change. Both erosion from water and wind greatly decreased during this period. We can take a look at one graphic that comes out of this NRI report, and it shows some really good and important things. We're looking at erosion between 1982 and 2007. Here on our chart, we're looking at years 1982, 1987, 1992, 1997, 2002, and 2007. The blue represents sheet and reel erosion rates, and the yellow represents wind erosion rates. And then we have a total amount of erosion in billions of tons per year. And again, the erosion, total erosion in the United States in billions of tons per year. In 1982, we had over 3 billion tons of erosion on cropland. And you can see that this erosion rate has gone down to about 1.73 tons per year, 1.73 billion tons per year in 2007. And today it's about 1.46 billion tons. So since 1982, we've reduced the erosion rates by over 50%, or we've reduced the amount of erosion on cropland by over 50%. That's definitely progress. We need to keep this downward trend going. That bar graph shows that between 1982 and 2007, soil erosion on U.S. cropland decreased by 43%. Again, it's over 50% if you measure it all the way to 2018. Water erosion decreased from 1.68 billion tons to 960 million tons per year. And wind erosion declined from 1.38 billion tons to about 765 million tons per year. So the erosion rates declined significantly. Water erosion from 4 tons per acre in 82 to 2.7 tons in 2007. And our wind erosion rates decreased from about an average of 3.3 tons per acre in 1982 to an average of 2.1 tons per acre in 2007. So we have statistical proof that erosion rates are getting lower. That should translate into lower sedimentation rates in the big rivers in the United States. So if we take a look at erosion reduction in the United States, we've done the big, easy erosion reductions. They occurred in things like reducing tillage practices, better irrigation management. So we did the easy things by 1997. We continue to do things, but the rate of reduction has slowed. And that's simply because we've already done the easy things. If we look at the erosion hotspots back in 1982 by taking a look at a map, you can see, again, water and erosion. The blue represents water erosion, as you would expect. The blue pretty predominant in the wet areas of the Midwest, in eastern Washington, northern Idaho. That's a pretty wet area. A lot of erosion is due to water. The red areas represent erosion due to wind. You get into the Columbia Basin of Washington and Oregon, and on the eastern Snake River Plain of Idaho, there's more wind erosion. And across the Great Plains, we have a wind erosion hotspot, and in the Dakotas. This area that I'm circling right now, this is the Great Dust Bowl region. If we take a look at a similar map produced in 2007, first of all, before I switch slides, take a look at the magnitude or the intensity of the colors of dots. We go to 2007, and we still have a lot of dots, but they aren't as plentiful as they were in 1982. You can still see the general areas of the country where we have hot spots for water erosion, and the red spots, which represent where we have hot spots for wind erosion. So we see that erosion is concentrated, before I go ahead, I want to go back to the Mississippi River, the last lecture. We have a lot of water erosion in association with the Mississippi River, and that's why the Mississippi River is one of the major rivers in the world carrying sediments. Whereas if we look at some of the other rivers in the United States, we look at the Missouri River, the upper Missouri doesn't carry a lot of sediment. The Columbia River doesn't carry all that much sediment because there's just one big concentrated area of farmland along the Columbia and along the Snake River. So erosion in the United States is concentrated geographically. We divide the United States into 10 agricultural regions. 54% of the water erosion is concentrated in 2 of the 10 agricultural regions, regions we call the Corn Belt and the Northern Plains. So there's where the majority of our erosion occurs. Water erosion. If we take a look at wind erosion, 93% of the wind erosion in the country is concentrated in 4 of 10 agricultural regions that include the Northern Plains, the Southern Plains, the mountain states, which would include Idaho, and the lake states. If we put all this data together, and we look at soil erosion tolerance values, in 1982, 40% of the United States cropland exceeded the soil loss tolerance levels, which means we're losing soils faster than they are being remade, basically naturally created. In 2007, we had decreased from 40% of the cropland exceeding soil loss tolerance down to 28% of the cropland exceeding soil loss tolerance. So progress is being made. So where we had the excessive soil loss in 1982, it's exactly where you expect. And if we look at excessive soil losses in 2007, they're not as intense because we've decreased it by another 28%. But if we look at the Pacific Northwest, you can see the excessive soil loss. Still hot spot in the Columbia Basin of Washington and Northern Oregon, a little bit in the Palouse, and on the eastern Snake River Plain. But if you take a look at the Pacific Northwest compared to the rest of the country, erosion rates are not that high. Of the 10 agricultural regions in the United States, the lowest erosion rates are in the northeastern part of the country. We would suspect that because the Northeast is not an intensive farming area, and the highest erosion rates are on the Southern Plains. The difference, less than 3 tons per acre is the average erosion rate in the Northeast, and almost 9 tons per acre is the average erosion rate on the Southern Plains. Just to quickly show you, this is how the United States is divided into agricultural regions. We have the West Coast, we have the mountain states, which we're concerned about. So if we take a look at the Pacific Northwest, Washington and Oregon would be considered in the Pacific agricultural states. Idaho would be considered as part of the mountain agricultural states. Okay, so we can give you numbers and numbers all the time, but what is a sustainable soil erosion rate? It's believed that a sustainable erosion rate for soil quality and soil health is 4.3 tons per acre per year, which means through geologic processes and weathering processes, about 4.3 tons of soil are made each year through the geologic processes. If we lose more than 4.3 tons of soil per acre per year, we're not sustainable. So our goal is to have less than 4.4 tons of soil lost on an erosion rate per year when we talk about soil health and soil sustainability. So we're making pretty good progress in the reduction of erosion on agricultural land. First of all, you have to remember the population density is much higher on continents like Asia and Africa. The increased population density has resulted in pushing agricultural lands to increase production at all expense. The bottom line is we need large amounts of food produced per acre. We don't have the luxury in these Asian and African countries of setting aside land to protect the land from erosion and things like that. So as a result, erosion rates in less developed countries are 5 to 50 times the rate compared to U.S. farmlands. One of the hot spots in the world for erosion is in the Sahel region of Africa, which is a dry savanna area of Africa where the population is greatly increasing, and we have a lot of wind erosion if we don't properly till the land. So we have lots of situations where land degrades. You can see this cropland here in the Sahel region of Africa. You can see that gullies and stuff are starting to form. Again, as populations increase, they're farming steeper slopes, and there's not much buffer area of vegetation. All this soil is exposed. You get high intensive rainfall, and you start losing soils fast. In the Sahel region of Africa, wind is always there. If wind is intense and you have bare soil, you end up with lots of erosion. And windstorms such as this one in northern Africa is carrying tons and tons and tons of soil with each storm away from the productive farmlands. We look at a country in the Sahel region of Africa, such as Senegal. We can see deserts encroach on savanna or farmland. A very difficult situation. So the erosion war is being lost in many less developed countries, particularly in high population density areas of the world, such as Asia, particularly Southeast Asia, and Africa. So let's take a look at the physical features of erosion. There are several different types of land-based erosional processes. Ultimately, eroded materials enter surface water bodies, negatively impact water quality. So this is the erosion is the source, and what we see when we look at pollution of water, it's the sediments actually in the water. So let's take a look at some of the physical features. If we take a look at rainfall and surface water runoff. Rainfall and surface runoff produces four main types of soil erosion. This is getting technical. If you've ever had a soil physics course, you probably know a little bit about these. Splash erosion, sheet erosion, rill erosion, and gully erosion. We go from very simple, not very destructive splash erosion all the way to very, very severe gully erosion. So let's start with splash erosion. Splash erosion would be the impact of a single raindrop on the soil. The raindrop creates a small crater which ejects soil particles. So here's an example of splash erosion. You have a single raindrop hitting the exposed soil. Looks like a little bomb exploded there, but you have soil particles that are ejected. More technical type of diagram. Again, one simple raindrop coming down disrupts the surface of the soil. And you can do the math and look at trajectories and talk about the significance of splash erosion. It's much more significant on a sloped soil than flat surface. The best way of preventing splash erosion is having the ground covered with vegetation. If the ground's covered with vegetation, it's the vegetation that bears the impact of a single drop of rain. You remove the vegetation, all of a sudden the soil becomes susceptible to splash erosion. Let's go a little bit more severe. Let's look at sheet erosion. If the soil is saturated or the rate of rainfall is greater than the water infiltration rate into the soil, you get sheet erosion. Sheet erosion is simply the transport of loosened soil particles by overland flow. A good way to take a look at it is here's a picture of soil that has some sheet erosion. Basically, if you take a look at the surface, you can see that where we've had sheet erosion, it's a little bit flatter. So Here we had a case where it rained fairly hard, and the soil was not able to soak up all that water, so that water ran off the surface. So sheet erosion is not that severe, but it can lead to rill erosion. Rill erosion is the development of relatively small water flow paths across the soil. A relatively large amount of soil can be moved off-site through what we call rill erosion. We see rill erosion on small hills. The water flow path varies from a few centimeters to several inches. Here's an example of rill erosion. In sheet erosion, you saw very little disturbance of the soil surface. With rill erosion, you can see that the water is cutting down and removing a lot more soil, and the loss of soil is pretty significant. Then we go to the most severe type of water erosion. We call that gully erosion. That can occur during or right after a major rainfall event. We remove soil to a considerable depth, this process does, and you end up with a major soil loss. Here's an example of gully erosion. You had a big storm, the soil wasn't protected, and the gullies were cut in the soil, and tremendous amounts of soil were moved downstream, ended up in a surface water body, caused sedimentation in that surface water body, and everything goes downhill from there. So rainfall and surface runoff cause soil erosion. This lost sediment ultimately ends up in our local rivers and eventually the oceans, resulting in degraded surface water quality, degraded ocean water quality. So let's take a look at some of the physical features. Let's look at rivers and streams. Rivers and streams cause significant erosion by themselves. Valley or stream erosion occurs with continued water flow along a linear surface. So rivers and streams actually cause erosion. They're banks along regular surfaces. Valley stream erosion cuts the soils both downward and headward, extending the valley to the hillsides. This creates both head cuts and steep banks, and you've all seen these things. In the early stage, we get a V-shaped cut, a steep downward cut, then a base level is reached and no more downward cutting occurs. And then there's a change to lateral erosion. This widens the valley floor and creates a floodplain. Today, in most river systems, we're most concerned about stream bank erosion. It's the wearing away of banks of a river or a stream. We can get some thermal erosion, melting and weakening of permafrost due to moving water. We see that in Arctic type climates. So here's stream bank erosion, a picture of stream bank erosion. You can see the river slowly cutting the stream bank, and we are losing a lot of soil this way. It's entering the river and moving down as part of the sediment. Most river erosion occurs near the mouth of the river, where the river is wide and slow flowing. So it's just not agricultural land that causes erosion. Rivers and streams cause erosion. This lost sediment ultimately ends up in local rivers, eventually the oceans, resulting in degraded surface water quality. So we have erosion on agricultural land. We have erosion caused by rivers and streams. Then we have erosion along coastlines. Shoreline erosion occurs on both sheltered and exposed coasts. Erosion is caused by the action of both currents and waves. Tidal changes also cause erosion. So coastal erosion can be pretty significant. Some of the things we see are wave pounding, the energy of waves hitting the land. They break rocks off coastal formations. the sediments transported along the coast in the direction of the prevailing current. So coastal erosion is also an issue. Coastal erosion results in soil erosion and runoff. This lost sediment ultimately ends up in the oceans, resulting in degraded surface water quality. Another mechanism of erosion that we don't think about very often, but we know occurs, is erosion caused by glaciers. Erosion of rock by one of three processes: the abrasion or scouring of ice, the plucking of rock by ice, and ice thrusting. In old times, glacial erosion was very important. Not quite as important today, as there are fewer glaciers in the world, and the glaciers that are there, many of them are receding. So as far as an erosional process from a glacier, we have the abrasion scouring, where the debris and the basal ice scrapes along the bedrock surface. It polishes and gouges the underlying rocks. It's similar to the action of large grit sandpaper going across wood. So glaciers cause land erosion. This lost geologic material ultimately ends up in our local rivers and eventually the oceans, resulting in degraded surface water quality. Then we have floods. At high water flows, the rapidly rushing water can cause extreme erosion events to occur. Lots of areas receive a major flood a year, and during that flood we have the highest erosion rates of the year. Historically, we can see the effects of some major floods. If we look at the Pacific Northwest, we look at eastern Washington, we have a geologic area called the Channel Scablands. We had a major flood that occurred over a period of just a few days, and it wiped away tremendous amounts of soil. Then we have wind erosion. We have a lot of problems associated with wind erosion. The wind erosion can cause land degradation, desertification, for instance, in Africa, and harmful airborne dust that adversely affects human health. In addition to land degradation, desertification, harmful airborne dust, wind erosion increases water evaporation. It can damage crops, and it can degrade surface water. We have two types of wind erosion that need to be considered when we talk about erosional processes. We have deflation, where the wind picks up and carries away loose particles. So if the soil is exposed, the wind comes along, a gust of wind, it will pick up and carry away loose particles. The second type of wind erosion is what we call abrasion. And these are where the surfaces are worn down as they are struck by airborne particles. So let's take a look at deflation first. Three types of deflation. We have what we call surface creep, where larger particles roll along the ground. Then we have the process of saltation, where particles are lifted up a few feet off the ground and bounce along the soil surface. And then we have suspension, where we have small particles that are lifted into the air and carried long distances away. So this wind erosion causes soil erosion. The lost sediment ultimately ends up in our local rivers and eventually the ocean, and this results in degraded water quality. So lots of things cause erosion. Some other erosion processes, we can take a look at mass movement. Mass movement is the outward and downward movement of rocks and sediments on slope surfaces. Mass movement occurs primarily because of gravity, and this explains material moved in the mountains from higher elevations to lower elevations. This is mass movement. Other terms associated with mass movement include landslides, which are sudden mass movements of materials, and then we have slumping, which can occur on steep hillsides. Just like the other processes we talked about, mass movement causes erosion. The lost debris eventually ends up in streams and rivers and the ocean and degrades water quality. Then we have some factors that affect erosion rates. Climate. Precipitation is the most important climatic factor affecting erosion. Both the amount and the intensity of the precipitation is a key process here. Erosion is most severe if the soil is not covered by vegetation during a heavy rainfall event. One of the practices we use in American agriculture, a best management practice, is to try and keep the soil covered with vegetation. If you keep the soil covered with vegetation, you will minimize erosion. So in the United States, a rainfall intensity is a main factor determining the erosivity of soils. Higher rainfall intensity, more erosion. Now, the size and the velocity of raindrops also affect soil erosivity. Large raindrops have a higher kinetic energy. Fast-falling raindrops have a higher kinetic energy, so they are more erosive. Vegetative cover is an important factor. Vegetation protects soils from erosion. Vegetative cover increases the permeability of soils to resist erosion. Vegetative cover shelters soils from wind erosion. So vegetative cover goes a long way to prevent erosion. Vegetative roots bind the soil together, reducing erosion. So if you have plants, the tops of plants not only protect the soil, but the roots of plants bind soils together, reducing erosion. You remove vegetation, you increase surface erosion. The percentage of vegetative cover of a soil is also important. In general, the greater the percent of vegetative cover, the more stable the soil. This is really an important concept when we move to looking at rangeland. Rangeland, where the vegetation completely covers the soil, has very low erosion rates. However, if the rangeland has degraded or it's been overgrazed and large patches of land or the soil is exposed, you get higher erosion rates. So the lower the vegetative cover in rangelands, the more soil loss, the higher the erosion rates. Topography, also another factor that affects erosion rates. It determines the velocity, T, which water will flow over land. Long, steep slopes are more susceptible to high erosion rates. These are just common sense things. Steeper terrain is more likely to lose soil and have landslides, mudslides, and combined with other gravitational erosion processes. Then we look at development. Human land development accelerates erosion. Agricultural development. Again, we've talked about erosion due to agriculture. It's a big deal. But when we go outside of agriculture, human land development will also accelerate erosion. If we take a look at urban development, here's an urbanizing area in a third world country. You start covering surfaces, you start doing things, and you'll start seeing more erosional events. Human land development accelerates erosion. You start removing trees. That exposes soil, and you start to see huge erosional rates. Here's a landscape in the country of Madagascar. If you take a look at a picture of this landscape, 30 years ago, it was pretty flat land. But as the forests have been cleared and you have high intensity rainfall events, you basically have a land that's full of gullies, and you would have never pictured this as flat land. Same thing, mining. Have a lot of mines, mines that are closed. You end up with lots of erosion associated with those mines. So it's just not agriculture that's responsible for erosion. We have a lot of things that humans develop that cause erosion. Human land development accelerates erosion, dredging and channeling rivers. As we've modified rivers for shipping and our conveniences, we've created a lot of places for erosion to occur, such as this stream bank right here. You can tell that stream bank is definitely not stable. There's no vegetation on it. We're going to lose a lot of sediment there. We're going to lose a lot of soil there. That soil is going to become sediment as it enters rivers. It goes downstreams. It creates havoc through making the water more turbid, which hurts water quality. It gets deposited in the middle of the stream. You might have to dredge it. You might have to dredge the harbor because of it. So everything is connected. So sedimentation and erosion are very closely connected. Thank you for your attention, and we'll move on to another topic in our next lecture. In this country, erosion rates today are basically 20 times less than what they were in the 1930s during the Dust Bowl. So that's really tremendous progress. So we have a highly developed technology that we're using in a country like the United States and in many other highly developed countries to reduce erosion losses. What's the situation in other countries of the world?